Let us learn from the experts sharing their views on engineering cooling technologies for data centers. I request Darshana to moderate session further.
It was a very engaging discussion. So, starting with our individual submissions, ladies and gentlemen, I'd like to introduce Mr. Ujjwal Singh Rao. Mr. Ujjwal is a counselor for green data centers at Confederation of Indian Industry-IGBC, with professional experience of around 10 years and skills in Precision HVAC Solutions Architecture. He is an ex-data center manager at the ICICI Bank. Previously, Mr. Ujjwal worked with Levanter Air Systems as a thermal management expert and project assistant at MNIT Jaipur, where he also applied for a patent on refrigerant charge monitoring. Today, Mr. Ujjwal will be sharing his view on green data centers.
Thank you, Darshana, for such a wonderful introductions. See, I'll do it very quickly, but there are some things that need to be taken to make a ground before we start talking about the cooling technologies, innovations, and everything. Where do we stand today? And before that, a small introduction of what we do at IGBC. See, IGBC mostly is primary a certifying body. We certify 31 type of topologies in total. That includes hotel, restaurants, it includes healthcare systems, it includes railways, it includes data centers, commercial buildings, almost every type of technology. And all topologies have a different rating system with the different requirements that satisfy and guide those buildings to become more green in nature. For data center perspective, we started in 2017 and till date we have covered almost 40 plus data centers, including all the hyperscalers that you can name of us as on date. We learned a lot of them from, and we helped them to go green in terms of their energy efficiency, water conservation, waste management, and operational techniques. Let me start with the basic statistics. In 2018, we were at almost 300 megawatt total IT capacity in India. It's a report from the JLL I'm quoting here. And we have grown almost 3 times from 2018, and it is projected will grow twice what we are on date by 2025. We are likely to cross 2 gigawatt mark, which like everybody, all the data center stakeholders, whether it be OEM, operator managers, people like us, SDOs, everybody should pat their back on that front. I'll briefly tell you about the story of data centers in India. So it started getting boom in 2007 when we had the 3G phase entered India. And it accelerated in 2012 again, then when we had the launch of 4G in place. As on date on 2017, we were looking at a lot of e-commerce starting in India. We started from ordering food, then we booked Ola cabs, then there were a lot of OTT platforms available with a lot of contents, Netflix, Amazon Prime, etc. Now we have, even if you want our toothbrush, you will order it through Blinkit and order it at your home. So now everything is going e-commerce, and every e-commerce website requires a data center in the back. So that is what it is pushing India. Government has started publishing Digital India, pushing Digital in India. And recently they have told about the data localization that they are going to implement. And 5G is already introduced. These two factors will make the India almost twice the capacity we have on today in next 3 years. Now let's talk a small thing about why India, why Indian data centers are growing, why not Pakistan, Sri Lanka, why not anybody else. So the major reason for this is that we have the second lowest internet charges in the world, just beyond China. Internet is cheap in India. We use it at the max level, whether it's be Instagram, LinkedIn, or anything. We are constantly sticked on your screens. But see, it's not the only thing. Indian governments, they have done a good part. They have started doing exemptions in land subsidies, power tariff subsidies, fuel subsidies, and they are helping it. We must have recently seen the interviews by Yogi Adityanath. They have supported a lot on the data centers in UP. Going forward, like the good part about India is cheap labor, as you all know. Indian data center construction and operations cost 60% less than what we do in our European brothers or USs. And that is one of the key factors that interest all the data centers to come in India and operate from here. And last but not the least, we have a good amount of skills. Indians are skilled people. We all must appreciate this. People around the world require us. And now we have a good opportunity in India, and we try to use it to our best. This is something that inside I'll be sharing of IGBC itself with you guys. In 2016, when we started, we were looking at POE trends of 2 and above. And like, see, There are many culprits to it. Lower IT allocation was one of them, which I should not say culprit, but was one of the factor to it. But majorly it was the inefficiency of the data center back then. There was not much knowledge to anybody how to operate and everything. Various agencies came together and helped. There are various publications and everything. The OEM developed themselves, they improved their products, everything contributed for this. And from 18 in the 20th, we were at 1.55. Currently, we are below 1.5. Most of data centers that we now go and certify, we see their PUE somewhere in the range of 1.4 to 1.5, which is a good sign because Uptime published global data center average PUEs, and we are below that value, which we should be very good and proud of. There are good data center examples where the PUE is even 1.12, 1.18. I can name Infosys, I can name Reliance and others. Louis Saab is already there with us. I think India is heading towards a good future in terms of energy efficiencies. I'll talk shortly on the cooling front. See, the cooling efficiency is directly related how close your cooling system is to your server. I'll start with crack unit. And using a cold aisle containment or hot aisle containment, you can get a PUE, even you can get a better PUE like 1.5, 1.4. I'm talking the general sense here. So don't quote me when I talk the PUE value here. But in general, you get a relatively 1.7, 1.6 PUE when you are using a crack unit with a cold aisle, hot aisle arrangement. Now, if you move your unit and place it in between the servers, you get the in-row cooling system. In in-row cooling system, since the circuit is shorter and the controls are very much more efficient compared to that, you get a better PUE and a better control in the systems. Moving even ahead of this, it's a rear door heat exchanger. There are good case studies available on the internet. You just need to Google rear door heat exchanger capacities in installations in India. What we have done is we pushed a door in the behind of the servers that is made of a heat exchanger, and we supply coolant into that. Can be water, can be any two-phase or three-phase or single-phase liquid. And that door, what it does is, as the air passes through the server, immediately it gets cooled by that rear door. So there's always a cold aisle containment in the complete server area. Moving even ahead is direct-to-chip liquid cooling, where the most heat-generating part, that is CPU in the motherboard, that is getting cooled through a liquid, and rest of the components are getting through air. So it's a hybrid combination of air plus liquid cooling. Then we go to the final, which we have already discussed a lot, that is liquid immersion cooling, where you can achieve the PUE as low as you can. That's all about the cooling trends that are there in India, and they're relatively PUEs that you can see. Some of the small cooling trends that I wanted to show that we have seen in the new data centers coming in India. The chilled water temperature initially were around 7 to 12. We saw a good development. It got improved to 10 degree supply and 15 degree return. And these days, most hyperscalers, it is like a proud moment for us to share this. They operate at 20 to 21 degree supply air temperature. They spend a lot of money to make heat exchanger that is compatible with getting this water at 21 and still delivering 23 degree supply air in the cold aisles. So I commend all the DC owners that has applied this technology in their DCs. Adiabatic free cooling, I think Muntas is there with us. They will be elaborating a lot on this. I'll just touch briefly that there are two different kind of evaporative cooling mechanisms that we have seen currently working very well in the DCs. One is you use evaporative cooling to evaporatively cool your condensers. Every chiller manufacturer, I think Train must be agreeing with me, has now started including adiabatic kit along with their chiller systems, which helps in improvement. And second is dry cooler. Dry cooler is when your ambient temperature is already too low. I think with the limited time, I'll cut short my PPT over here. Thank you.
We request our delegates and viewers to stay connected with us on our social media handles. Thermal Control Magazine is available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. With this, we want to announce the closing of today's session. Request you to stay tuned for more such sessions. Thank you and goodbye.